Boop. Yay. Welcome back, guys. Last week we spoke about sort of the requirements that we're looking at for having validators on our network. Today we're doing something a little bit different. It's Kelly and I spoke, and she said that I have the hour to talk about basically what makes Silvermint unique in terms of proof of stake network. So similar to last week, what I kind of want to do is just show you guys a presentation, but I want to be able to have an open conversation about some of this stuff. So like if there's something interesting specifically around like the rules around Silvermint and like how we gain consensus, like please stop me. I would love to hear your feedback anytime. It's not like a solid, just I'm going to sit up here and give the presentation for an hour. This is very much an open dialogue. So for housekeeping, tomorrow we're also going to have Kelly. She's on the call right now. She's going to have an hour for tomorrow, same time that we've been doing, 7 o'clock Mountain Standard. But she's going to be going over product and basically roadmap, if I'm not mistaken, right, Kelly? Is that what you're doing tomorrow?
Yeah, I'm going to talk a little bit about the roadmap. I also want to talk about kind of areas that we are looking to accelerate in the ecosystem.
Cool. Well, that is what she will be covering tomorrow. So if you have any questions beforehand, make sure to shoot over in Discord, just so we can have kind of like an outline for her if you want something answered. So let's dive into this. So I've made this presentation specifically for people that, well, first of all, kind of have anywhere between little to medium experience. So Jared might not get a whole lot out of these first couple slides, but as we start diving deeper into the rules around Silvermint, I think that's going to be kind of a nice platform to generate some conversation. So obviously the topics for discussion today, we're going to just be going over very roughly what is a node operator, Silvermint node discussion, so what makes us different, and then we're going to just open up for comments and questions at the end. So let's dive into this. Right off the bat, I think that it's very important to kind of discuss this because there's a lot of people that don't really understand. There's two major consensus algorithm models, and we always hear this in the space. There's proof of work and proof of stake. It's my opinion that marketing and sort of there's a lot of different noise and people wanting to be unique in this in blockchain. And what's happened is we've gained a lot of different consensus mechanisms with their own names. So like proof of legitimacy, proof of space and time, proof of authority, proof of history, all these ones mentioned. But if you really read into the white papers, they almost always will say like similarly to proof of stake, similarly to proof of work. And really that's kind of what we're going to be diving a little bit into today is just proof of stake, because that's what Silvermint is. Silvermint is a proof of stake. It has its own rules. It has its own consensus mechanism that we call Casanova. But just kind of at a high level, this is a very childlike trying of mine, kind of building out what a network is. So right here, just kind of walking through very top level, there's a gentleman here. He runs a specific type of node software on a server, whether that be like, and this is different for different types of proof of stake, but like it could be, a server in your basement. This could be, a cloud infrastructure. There's some nodes that even like will run on like your phone or, anything really that hosts that software and connects you to that network. Similarly, there's like coins that are staked from a linked wallet, meaning that, the whole thing with proof of stake is that you need to have some portion of tokens to be able to join that network. That might be 50 tokens, that might be 10, that might be 7,000, that might be 8,000. Really depends on the actual blockchain. But in particular, you always just have to link something. And sometimes you don't even have to link a wallet. But for most of proof of stake, this is kind of the general outline here, is that people are all sharing the similar, I would say infrastructure as this validator here. They're all communicating with each other. As transactions enter the network, depending on their consensus mechanism, whether it's stake weighted, whether it's like a round robin, whether it's random. Jared on the call has spoken about some of these where it's like the first person to get the next transaction or validate the next transaction is based on who last joined the network, incentivizing people to like join the network and, you know, increase the node operators on it. So kind of speaking at another high level here, there's a lot of proof of stake commonalities that are shared with Silvermint, right? So there's going to be stake required to become a validator. We spoke about this last week. There isn't necessarily, we don't feel comfortable right now telling you exactly how many tokens that is. We don't feel comfortable telling you specifically how long you're going to have to stake those tokens for, but there will be a requirement based around tokens and linking your wallet and making sure that everyone has a certain amount of stake for a certain amount of period. So you're not going to be able to just like pump and dump the network. There's slashing penalties for being unreliable. So this is different for different proof of stake networks, but most of them have some slashing, mechanism in place for anyone or validator that's trying to sort of game the network, right? So this could be like trying to slow down the network. This could be for people that are trying to jump in line for getting the next transaction they're trying to validate. And obviously, like most other proof of stakes, in comparison to proof of work, it's energy efficient. There's not required specialized hardware in that you don't need like a bunch of graphics cards. You don't need like specific like mining rigs, right? And you know, validators and mint coins. So just like what I'm trying to say in this this slide is just that there's a lot of commonality shared with Silvermint, and this is kind of the ones that are shared amongst most proof of stake, to be honest. Okay, so what makes Silvermint unique in the proof of stake realm? So first and foremost, validators require equal stake. We're going to get a little bit into this, but there isn't stake weighting on Silvermint in that the more stake you have on your node, you know, in other proof of stake networks, basically the more tokens you have, the higher likelihood you have to get the next transaction to validate, right? We don't have that here in Silvermint. We actually have equal stake. I'm going to speak a little bit more about this in a second, but the second thing is we have bandwidth requirements. Third is that we are leaderless, we are no voting, and we have no gossip. So let's dive into this equal stake because it's really, really important. So first of all, with equal stake, kind of like what I was mentioning a second ago, it's kind of easier to see this little graph. I hope you guys can see it. But what's happening here is this is a proof of stake, stake weighting on a blockchain network that, you know, basically gives you a higher chance the more stake you have on your validator. So in this case, you know, Bob and Alice both have, they're both validators on this network. Bob has staked only $100 worth of tokens. Alice has staked $1,000 worth of tokens. And by doing so, Alice actually has a 10 times more likely chance of getting the next transaction on the network. So in a lot of ways, people see this as unfair. What's different and unique about Silvermint is that each node will actually have equal stake. We, again, as I mentioned earlier, we don't have an exact number. So this could be 5,000 tokens, this could be 10,000 tokens. We're not going to tell you exactly right now, but we will eventually. What this does, though, is that it improves decentralization, network security, and really prevents censorship on the network. And what's kind of unique about it is that a lot of this has to do with, and fundamentally, this affects kind of the Nakamoto coefficient that we see kind of toted. And for those of you who don't really understand what Nakamoto coefficient is, basically Nakamoto coefficient is this standardization of how many nodes you need to take over to compromise a whole network. So depending on the actual infrastructure of a blockchain network, it could be as little as like 7 nodes that you need to corrupt to control the whole network, right? With Silvermint, we actually have a Nakamoto coefficient greater than 600. And we actually give a lot of, kudos to our equal stake mechanism for this. Do you guys have any questions about this? Because this is kind of unique in terms of proof of stake. I'm going to say silence is consent if no one has questions. Okay. Minimum bandwidth. So what's again, unique with Silvermint is that we have a minimum bandwidth requirement. It is 1 gigabit a second, and that is a requirement for all validators on the network to have. So we really do believe that the more bandwidth on the entire network means more network throughput. And what's going to end up happening is if you have a dip in your bandwidth, basically you have a likelihood of actually being kicked off the network, especially if it's a prolonged period of time. We've spoken internally about this, about potentially being slashed from the network, potentially being put in a timeout. But the truth of the matter is that if you can't keep up with the 1 gigabit a second requirement, there is a chance you're just not going to be able to participate. We have something called stake as a leaky bucket. So to make sure that each validator is contributing and meeting the bandwidth requirement, we have this mechanism in place that what it does is essentially take your stake, and there's a slow, very, very minimum slow leakage of stake that comes out of what you've staked on the total network. But the way we kind of, incentivize this is that by participating in the network and by each validator contributing to validation and block creation, you're essentially given a reward for each one of those validations, and there's enough to offset the actual leaky bucket. So if you are a validator participating in the Silvermint network and everything is up to snuff, so you are meeting your requirements, you are doing the validating that you're saying you're supposed to, there's blocks being created, there's validation, you're never even going to actually see this. You're just going to see an increase in your stake and essentially your accounts. But if there is, for some reason, a reason why you're not participating in the network, you're going to see a small leakage from your stake. And we're hoping that kind of incentivizes, validators from participating, incentivizes them from participating the way we want. And it's not that the stake is actually going to leak down to zero. So if there's like 70,000 tokens, it's not like it's going to be like 70,000, 60,000, 50,000. It's going to be very small, very, very small. But eventually, before it even gets to the point of getting to zero, you're actually just going to be ejected or rejected from the network. Ejection for equivocation. So this is just slashing, but specifically in our white papers, it's called equivocation. When a validator is behaving incorrectly, they are said to be equivocating. So any account holder can present evidence of equivocation on the network, and that'll punish the validator and reward the reporter. So if for some reason there is a belief that a node operator is behaving improperly, there's going to be a mechanism in place to be able to basically report them for any issues that they might see. And again, we will reward the reporter. Any questions yet? I don't think so. No. Okay. Validator rules again. So this is the lazy validator challenge. What happens in a lot of different proof of stake networks is that there are ways for a validator to sort of game the network. And Kelly, did you say something? Sorry. No, okay. There's ways for validators to kind of game the network. And the way they go about this is, instead of giving and dedicating full computation power and full resources, they actually kind of withhold a little bit of that computation or throughput or whatever it is that's costing them money. So the idea is that they're actually increasing their profit. The way we get around this is the Silvermint protocol will actually issue a token to a validator that allows them to inject fault into a block. So what that means is, like, if I'm a validator and I'm issued this token, I can inject something in the block, a transaction that's not entirely true, or maybe it's incorrect. And what happens is, when I insert that into a block, the validators on the Silvermint network, if they start building on top of this faulty block that has issues with it, they're essentially punished because they've not actually seen the faults in the network. However, if a validator actually notices that there is a fault in that, they can go to the network and be like, hey, Nicky just tried to essentially game the network. They try to mess up the transaction, try to do something. I can present that token and say, hey, I was presenting fault into a block, and I was just making sure that, the network's happening, or the network is correcting itself the way it should. And essentially there is, nothing that happens from that. But that's essentially how we keep lazy validators in check. So I'm gonna check quick. So no censorship. So if a validator accepts a transaction, if I have a validator or a node and it's accepting a transaction, it must be published as soon as possible. And basically what that means is I can't withhold that transaction from entering the chain. And doing so actually very much opens me up to be slashed from the network. And then economic incentives. In the beginning, when we first have the Silvermint network up and running, essentially there's going to be two primary forms of incentives. Some of you are going to be familiar with the second one, but the first one is going to be rewards for block production. So as we create more tokens, or as the validators are spun up and tokens are created, there's going to be rewards for block production. And then second, which most people are familiar with if you've ever seen a proof of stake network before, is transaction fees. So once the network's fully up and running and there's a lot of transactions happening on a network and it's a healthy network, the fees that are actually occurring on that network are given to the validators. So, I mean, this is very much a, not putting the cart before the horse type of situation. Like obviously when a network's first spun up, there's going to be very many transactions. I mean, that's just kind of the nature of creating a new network. But as time goes on and, people are actually using this network to purchase things, to facilitate trades, to whatever they're doing, the transaction fees are obviously going to start accruing in mass amounts. And that's kind of how we're going to incentivize validators. Hopefully, I think that's the last one. So I'm hoping you guys have a few questions and we can have some conversations around some of these rules if you have any, or if you've participated in other networks. I think it's important to also hear, like, if there's rules or something that's different that kind of stuck out to you, I would love to hear that. Okay, I'm going to stop sharing this. Actually go back here.
No, actually it seems pretty cut and dry and simple.
Well, that's good. I like to hear that.
No, Nick, this is really good. I think this is a good baseline that you've put together. It kind of highlights. I think this is a great deck that a lot of people I think will need, because you did a good job with this. Thank you for putting it together.
Oh, thanks, Jared. Yeah, I mean, it's important to understand just the differences between different networks. I think what we're trying to do as a whole with these office hours is just answer questions and kind of cut through the noise. And I think if putting together that little slide just helps people kind of understand the different rules for validators on the Silvermint network and the incentives that come from it, that kind of pays dividends for us, just because we have a smart audience and we have a healthy community. So that way, if you guys are talking out there, you guys have the right information too. I've just, like I said, for me personally, like in the beginning slides, I know there's a lot of noise when it comes to like proof of space and time and proof of, all these different mechanisms that really go back to, either proof of stake or proof of work. And that's just kind of how we see it. That's proof of stake in particular for us. It's like we are a proof of stake network, but we have differences because of the Casanova consensus algorithm. And we just want to help our community kind of understand that and be able to speak thoughtfully about it.
I think it may be worthwhile as well at some point to kind of flush this deck out a little bit more. I know a lot of us understand proof of work and proof of stake, but I would probably double down on your discussion around proof of work, proof of stake. I mean, remember, why did Ethereum, now there's a million reasons, but there's a really good marketing reason why Ethereum just flipped to proof of stake. If you look at the world nowadays, right, there's this whole green energy, global warming, yada, yada, yada. I think it's worthwhile to from a marketing viewpoint to highlight the perks and benefits of having a proof of stake type validation in comparison to the power consumption and why you're making some decisions around that. and like do a compare and contrast of like how much power Ethereum and Bitcoin were consuming compared to these validator nodes, and kind of tell that story. Because when you're talking with investors, you're, why is this different? Not only does it have tons of transactions, but it also saves tons of power and this, that, and the other. But I would double down on the story and the comparison between proof of work and proof of stake. And then I would double down again on the difference between proof of stake and proof of stake, because there's so many different like contrasts between the different solutions. But I think you've got to tell that story better for the investors, for the people that are getting into this, that, are looking at, blockchain and why is this different. I think it's really great start, but I think it needs to be doubled down on for the 101 type users, because a lot of people still don't understand proof of work versus proof of stake. And I think all of us on this call do. So we're kind of like giving you a pass here. But think about the users that don't know as much as us. I think you've got to double down on that, is what I'm saying.
Yeah, 100%. And the reason why I kind of did the transition between it's kind of like you're absolutely right. We can definitely double down and go into more depth around proof of work versus proof of stake versus everything else. But I think, a lot of people have actually either messaged me directly in Discord or texted me, or people that can't necessarily make these calls because they have day jobs. They'll tell me, Nicky, like I really want to participate in this. Like I really want to be part of Silvermint, but I don't even know where to start. And this is like what's kind of scary to me specifically, is that I think blockchain has kind of done a really bad job of teaching people what blockchain is and like sort of its use cases. And specifically, I find it super concerning that, a lot of my friends are in tech, right? Like they might be engineers, they might be, systems engineers, and they're having a hard time grasping some of these concepts. And I think if we can kind of, dumb it down a little bit for people to understand, so that way they can build upon it, I think you're absolutely right. For us, it's very interesting because proof of stake for us is kind of different. And I'm sure Kelly can speak a little bit more about this than I can, but like with Ethereum, with their merge and sort of what's come from that, their throughput really hasn't increased all that much because they look to layer 2s or ZK rollups to kind of help them out with the scalability. For us, proof of stake is much more of a throughput, it's a throughput issue for us. Like we can do these, what our white paper is essentially allegedly saying is that we can have 150,000 transactions per second. Specifically, a lot of that has to do with the proof of stake network and how we utilize DAGs, using that network. So it's very different for us. And I think you're absolutely right. Like when I create,
you just did what I'm
slide,
talking about. Put that in the
Yeah.
slide, because that's exactly what needs to be said. You did a great job there.
Agreed.
Yeah, so that's kind of the difference for us. But again, I think the slide deck is very much a growing thing. I'll add to it and make sure that maybe in the future, in a few weeks or months or whatever, we can talk a little bit more about it. And specifically some of these mechanisms that we talk about within the actual PowerPoint itself, I would happily, and I'm sure Kelly would too, we would definitely have Mike stay on here talking about specific things if need be, whether that's like, anything within the white paper that I kind of referenced.
Yeah. Yeah, it's interesting. I've met validators that have made the move from mining to validating. And one of the things that is often part of those conversations is mining is a fairly individual activity. You instantiate your node, you do the computation, and you hope you make the block. Validating is a much more collaborative activity. It's, when we talk about, the rules of validating, it's observing what else is happening on the network. The work of validating is attesting to what you see. And so, to make sure that the network is secure and performant, you also have to observe, when people are not doing when validators are not doing what they're supposed to do. And that's where that kind of those equivocation challenges, those lazy validator challenges, those censorship challenges, it's a much more engaged process across the network, I guess in distinction against mining. And it's a hurdle that sometimes miners have to come over to think more about what it is to validate, and what it means to be a validator. And we're looking forward to, as we have a test net, we can play those games together. We can join validators to the test net, and show what it's like to get a lazy validator challenge, to get a censorship challenge, and how the network, I mean, obviously it's protocol and code, so it's not like individuals making decisions what to do, but protocol and code means secure. That's how you secure the network that's looking to a test rather than mine.
So talking about that with Ethereum and their move to proof of stake, I was curious how much of their you guys were talking about how that affects the transactions per second, but they're still on a blockchain rather than a DAG chain on Ethereum, I believe. And so what is the play between those two things? Like how much of the huge transactions per second that you guys get is based on the DAG chain versus being proof of stake?
Want that one, Nikki? Or you me?
I mean, you can. I mean, totally.
Yeah. So a chain is one block on top of another, one on top of the other. You can build a chain in proof of work and in proof of stake. The proof of work and the proof of stake are the consensus algorithms, but the chain is a protocol for building, the state of the network, if you will. So the challenge with a chain is it is one on top of the other, and which means that if you have a group of, say, 20 validators, they have to take turns, one on top of the other. And that is inherent. I mean, by definition, that has to take time. You have to wait your turn. If you're some proof of stake consensus algorithms are called round robins. So every validator takes a turn to contribute their block to the chain. Some proof of stake protocols are called leader led. They have a leader, and that leader produces a block, and then there's a vote to validate that block is correct. And then sometimes the leader lasts for what they call an epoch, a period of blockchain time. And then the leader changes, but still it's one on top of the other. It's a blockchain. The key difference between chain and DAG, and the difference between Casanova and protocols that are leader led, is Casanova is leader less, meaning that, let's say we've got a group of 20 validators, they are all producing blocks on a schedule, but they don't have to wait one on top of the other. They just have to build blocks that trace back to and build legitimately on a previous block. So it's possible that I'm going to build on Nikki's block, and then I'm going to build on Allie's block, and then Jeff is going to build on top of mine, and we have, we can trace back to Genesis if we really wanted to. When you have a DAG, obviously you don't have to wait to produce the block. You're not waiting for your turn. You're not waiting to produce the very next one. You're relying on consensus and validation to attest that I can put my block on top of Allie's block because there's transaction history and there's parents that make sense, and therefore Jeff can build on top of mine, and Nikki can still build on top of Allie's, and then Jared can build on top of everybody else. We get to move faster that way. We don't have to wait our turn. And that's a key distinction. That's one of the ways that a DAG versus a chain allows for more throughput. And then you add to that, the fact that all validators are required to contribute a minimum bandwidth that increases the ability to have throughput. And then add to that the fact of equal stake weighting that incentivizes the addition of more nodes and more bandwidth to the network, and you're increasing throughput this way. That one of the big challenges in proof of stake protocols that are at the mainnet stage today is you actually see a throughput bottleneck. One, because they're leader led and they're building a chain. Two, because they're not incentivizing validators to add more bandwidth to the network. And so they will continue to experience that bottleneck if chain, even if they are taking a DAG approach, If they're not incentivizing the addition of bandwidth, they will continue to observe that type of transaction bottleneck when it comes to throughput. Does that make sense?
Yeah,
Yeah,
it does to me.
yes.
Okay.
Yeah, I like I mean, there might be people on the call that watch this later, but the way I kind of understood it a lot better is like with blockchains, like let's say Joe, like you are going to pay Jared $5, and like let's say I'm going to pay Kelly $5. There's no reason why those two transactions have to be ordered, right? Like there's no way that there's a double spend issue there, because when you pay Jared those $5 and I pay Kelly those $5, really it's not coming from the same wallet. There's no way that there's only an issue really if Joe, you try to pay Jared and Kelly at the same time, right? That's when a double spend issue might come in play, because you might be trying to use the same amount of money to give Jared the $5 or Kelly. What's happening in a blockchain is it really can't decide or tell the difference between those two transactions, because it's going to check no matter what. With a DAG, because we are essentially saying that there's no way that those two transactions are conflicting with each other, we can start building out sort of like linearly, right? Like a directed acyclic graph actually allows us to build kind of at all angles at all times, and allows us to see kind of all over the network, where blockchain is very particularly building one at a time, equal timing across from each other. I kind of hope that didn't confuse you, but that's kind of how I understand it. It's just a little bit easier to understand if you look at it in terms of double spends and how throughput can kind of affect that. Like I was saying, like if you're paying someone and I'm paying someone, there's no reason why the network can't say, okay, let's just add these two things together. And a blockchain really doesn't have the mechanisms in place to be able to do that.
Okay.
Yeah, that's
cool.
a
That makes
great
sense.
example. And then I think, the next step on that example is, when there's a double, it's not to say that of course, a double spend could happen.
Yeah.
In this scenario though, let's imagine Nicky paid $5 to Matt and me and is doing a double spend, and he's a validator. He gets slowed down while he gets that all sorted out and fixed, while the rest of us continue on with the work of the network. We don't have to slow down to reconcile that. Nicky did it. He's at fault. He needs to fix it. The rest of us can continue on with the work. I mean, that's another scenario where networks can slow down when there's a double spend, because everybody has to get involved in the reconciliation and fixing of that, versus in the Casanova protocol, the proposal is that the validator that proposed the double spend has to slow down, fix it, and then the network can continue, and he'll have to catch up. He'll have to do the work to catch up.
Yeah. I will let this, again, we can have open time for questions or whatever you guys want to go over. Specifically, I'll leave it up for a couple of minutes, and if not, we can end there. I know today was a little bit different just because we were going to go over specific rules. So it might have been a little bit shorter in time than normal. I just thought it was really, really important for our community to kind of understand how we're different.
Well, I might have a little technical question for you. When you get ready to build a validator node or a node, when I go get set up, I got to grab all the different files and import them into there to get everything set up to launch to the wallet. And when you launch, I mean, if you set up nodes before, I can't remember all the different program files I had to go grab and drag them all in separately and launch them all separately. When you guys get ready to do Silvermint, is there a way you can set it up as a package to where once you grab a note, grab a code and click on it, it just automatically chain links each one that needs to be put into the whole file to launch the node, to where it makes it simple to where a person doesn't have to go here and grab this off of GitHub and go here and grab this file here.
Oh my gosh, that's terrible.
Well, I've done it before, and then I had to write code in between. That way I wouldn't have to sit there and launch them each individual. So I go grab them all, And
Yeah.
then sometimes Jared would say, "Oh, you need this one here," and I go grab that one. And then,
Okay.
and then you put a little code in between them, so where you ain't got to sit there and babysit them. When one launches and runs, when it's done, the
Right.
next one will run.
And all
So
through that, you're hoping you're not introducing bugs, right?
yeah, exactly.
Ah,
And so hopefully, this is several years later. I mean, here we are, what, 7 years later. Hopefully when you guys get ready to do this, it'll be simplified to where a person can just go grab one code that you guys issue off your site or your GitHub and launch it, attach their wallet and hit start, and either it's good or it's not.
Yeah, I mean, that's certainly the goal. I mean, obviously, user experience matters, right? It
And
matters how complex.
Making it simple makes it easier for the people that don't understand or they're first time users.
Right. And so that's exactly what's happening in our internal test nets right now. Rusty is our systems engineer, and he has automated and packaged up very nicely Silvermint in ways that deploy excellently. Like he can, he's built, he's using Docker and Terraform and has got systems in place. We intend to share those with validators. We want that the goodness of that experience to be shared. I would say the caveat is this, like, a blockchain is by definition trustless. So it is important for validators to understand what code they are deploying, to make sure that you understand what's in that package, how does it work, that you've done your due diligence, which I don't think it makes it terribly onerous, but I think it's important to that there is some responsibility there. The risk in blockchain is somebody sends you a package that says this is a Silvermint node, and if you don't do a little bit of work to validate that that's truly the correct software, that's truly the package that you're receiving has the things that you need and want, and not the things that you don't, perhaps. So there is always going to be a little bit of due diligence, but Jeff agreed. We very much want the experience of a validator to be, very straightforward. It's certainly not going hither and yon to find all the things that you need, but also making sure that there's a sense of responsibility for what it is you deploy, especially, in a mainnet scenario where you've staked your node.
Sure. And I understand way hackers work. Eventually, once Silvermint gets to be some value to it, there are going to be people out there to make malicious code and say, oh, they might misspell Silvermint with 2 I's or 2 M's and say this is the original site, and somebody's going to grab it and it's going to extract all their funds out of their wallet, and then you're going to go like, what happened?
Right.
So yeah, you need an official site. You need, make sure everybody understands that they double check and triple check they're on the correct site before they launch something. Because I'm working with a gentleman right now that lost 2 million of my tokens through a trust wallet hack.
Oh shoot!
And they offered it back to him yesterday.
Okay.
And he went to go put $5 in this trust wallet because they put the coins in his wallet. He put $5 in there, and it extracted his $5. So it's a bait and switch, is what it is. They got a code inside of his wallet.
Yeah.
So that's what you don't want to happen.
Yeah,
it does. Nothing I can do about it because I've already renounced my contract. I can't go in there and blacklist it. So I can't help him.
Yeah.
It's interesting too, Jeff. I know you weren't on the first couple calls that we had with Rusty, but Rusty very much has the dream of like single line deployment, where he always makes references to, like, I don't know if you've ever had a MacBook or like used Homebrew before, but essentially just being able to type in one line of code, grab it, copy and paste it, and it basically spools up a node instantly. So that's what he's been working towards every step of the way. And I think that's what he always has in the back of his mind, just because he's the director of systems engineering, and that's kind of how those guys think. They want things to run really simple and they want it to be robust. And that's something that every step of the way, he's always making sure that he has at the back of his mind. So,
well, I mean, if you look at a lot of engineers, a lot of coders, they look at 50 or 100 lines of code and they go, oh, it's simple. Well, it is for you. You might have a PhD in coding. But when you got average Joe out there who didn't even go to college, whose second year into crypto is going, what's a node? Doesn't understand 50 lines of code. So yeah, I love that aspect of one line, boom, enter, go, run. That is sweet.
Yeah.
I want you guys to realize though too that for round one and testnet, we don't expect that nor care if it's there. We understand there's going to be more work. We understand it's going to be a little harder to deploy. Just we'd rather get the network going, and that's totally fine. For production, that's a different thing. The things that are concerning in production is, yes, single line, easy deploy, APIs, Kubernetes friendly, so we can deploy through like a Kubernetes type framework or something that we can manage, potentially hundreds of nodes through one interface. Monitoring, out of sync notification, things like that are really, really important. Because you get out of sync, or you have like a bandwidth drop, you get punished for it, which is totally right. But I want to be notified, so I want an API that notifies me that that's happened. So I can hold my provider accountable for some of those issues, or I can look for a new provider if I need to. So it's that logging, syslogging is really important. Things like that. Automated centralized deployment is really important. But that's production stuff. We just want testnet now. And
I appreciate hearing that. Yeah, and thanks for sharing. It's good to know that. In terms of roadmap, related to that, like where we are today, it's Silvermint is packaged really nicely today for ease of deployment. That's how we are able to run all the test nets that we are internally right now. So that's going quite well. There is monitoring that's included with the software today to a degree. I would say the weakest point in the software today, and the place that we will iterate towards production, this would not be a public testnet blocker, is really going to be in that API space. It's a rough API right now, meaning that there is an API. You can certainly engage with Node through the command line very, very nicely. It's not well documented in terms of like there's not a Swagger page yet. And there are aspects of the API that are probably still missing when it comes to production ready software. So that's kind of the roadmap as I understand it right now. Certainly package and ease of deployment is a priority because that helps people engage. And then the rough bits I think really are more in the API and monitoring space at this point. And actually it's important as part of public testnet to get feedback on that. Like where should we focus? We have a hunch about what's needed, but maybe you have another idea. And that's another reason to get it out there sooner than later so that we could start hearing that feedback and make priority decisions on how we iterate towards production.
I just wanted you to know that expectations are like correct expectations are set. We understand where, and it's important. Like I get it, but it may be important to have those caveats in the initial release notes that hey, here is current status. We love bug reports. We understand. We're working on it. It's on the roadmap. Having those roadmap items like defined so people know it's coming. And then, because there's a lot of these dumb questions that you're going to get from people. Are going to be like, yeah, we already know. Document.
Yeah. No, that's excellent feedback, Jared. Thank you for that.
We really appreciate your guys' communication and like keeping us in the loop, and look forward to helping the community grow and get all things dialed in. I mean, I'm by no means the smartest guy. There's lots more, and we'll work on gathering all those up and building the community.
Yeah, and but I also want to kind of add to what Jeff said too. Like I think we're very cognizant here at Silvermint, knowing that the easier it is for a user to join blockchain, the better it is for us. I mean, that's just kind of like, all in all, I think that's something we can agree upon. Everyone in this call likes blockchain to some degree. You guys are clearly in the community. You guys want to know more about it. But a huge part to make your guys' jobs or validators' jobs more profitable, or people in the space, happier, is to get more users. Like the user acquisition has kind of fell short in a lot of different ways, just because it is so difficult to even, buy crypto and use a wallet. I mean, the easier we can make things for people to actually use Silvermint, the better it is for all of us, and the better it is for the community as a whole. So we're very cognizant of that here. And I think a lot of that too, we bring into our stand-up meetings. We talk about, daily, like when we go to conferences, this is the type of stuff that's on the top of our mind all the time.
Another worthwhile slide to add, Nicky and Kelly, may be a slide that's titled something to the effect of, methods to profit. And I know that we've talked about a validation node, which is like a full node, which has some higher requirements. It's going to have bandwidth requirements. It's going to have you know, maximum amount of memory requirements. It's going to have a specific amount of stake that is required. But then I've heard mention of another type of ways to participate into the experiment around a light validation node that may be used for things like blockchain explorers and things of this sort. Now the rewards will be a lot less, but that may be just another worthwhile slide of ways that you can contribute and profit from participating in the network. But you want to map that out, right? That you want to show people that, hey, you don't always have to have X dollars worth of coins to stake. You also can help with blockchain exploring validation, with other types of things, which are what would be classified, I believe the term that I've heard thrown around as a light node. And you know, it's just another way to profit, and that might actually require no staking, but it's
No
needed.
staking. Yeah.
It's needed nodes on the network that do have a reward mechanism around them for helping validate it. But you want to sell that story of, hey, we've got multiple ways you can profit from participating in helping validate the network. Potentially, there may be a way down the roadmap where you could actually decide to personally stake your coins, like in a traditional staking fashion within a wallet. That's another light form of verification. So where now you potentially have, you know, the traditional form of staking where I say I want to stake 500 coins and I'm going to lock them up for 6 months, and it just acts as a light validation node. Doesn't need the heavy requirements. The reward is a lot less. You're not a full validation node, but again, it locks the coins, which creates supply demand benefit to the value of the coin and tokens that are created. But there's ways like that. But the slide title, I would be like ways that you can profit and benefit from participating in helping that. But I can think of 3 right there. So a stake, a full validator, and a light validator.
Yeah, that makes a lot of sense.
Just a thought.
Yeah, we've certainly talked a lot about the observer node. So validators on Silvermint will not have. They really won't have CPU and memory. Like it's really a bad idea for a node that's validating to also expose themselves to be block explorers. That's going to be expensive for that validator to do, just based on where we think the rate of throughput is going to be on the root shard. So yeah, absolutely. There's a business model for an observer node, not just one. Many, like any kind of DApp that needs to understand the state of the network, any end user who is looking to validate where is my transaction, and to be complete on that. And even, you know, an observer node could also, and I'm just spitballing here, but an observer node could also be a conduit to a validating node. So for example, I want to pay Nicky.
Or an index.
Exactly. So there's, and there's certainly the business model there. It's certainly not in, there was no reward structure in terms of block production. The reward is in the transaction fee. Like there's a fee for you, a small fee, but small fees add up. Like, so if I am an observer node and I've got, you know, thousands of people looking to me to understand the state of the network, small transaction fees add up. And that's how we project that those observers would be profitable.
I'll throw another grenade at you. That's really interesting thought. There happens to be a whole shit ton of GPUs that have now just become available. And think about you know, the machine learning, the indexing, there's a lot of benefit that you can do with GPUs. Did I lose you? There's a lot of benefit you can use with machine learning, you know, indexing, things like this. There may be a function to, I mean, you want to talk about some press releases that are pretty amazing. Think of a press release that says Silvermint has a method and a way for you to profit with your GPU sitting around doing nothing. And maybe that's just a way that it can act as an indexer or some GPU function. But you could literally put a whole bunch of GPU nodes out there. I know Solana may be worthwhile looking into. Solana does have an option to use NVIDIA GPUs for some indexing and some capabilities. But think about a way to capture some of those dead GPUs that are sitting around doing nothing right now. I mean, I went to $30-40 a day to 2 right now is my thank you Ethereum merge. But it'd be great to have another method that you could use those, and it would be a great press release that you have a way that there's a method coming that people could use those leftover GPUs that are sitting around. And there is compute capability there that might be able to add some value to the network. As per what that is, I don't know, but you have a lot of smart people that work at Silvermint. They'll figure it out.
I mean, I think you're spot on. Indexing Oracle. I mean, there's a variety of functions that a decentralized ecosystem needs beyond just validating transactions. Yeah, no, that's excellent.
One of the coolest use cases of GPUs I found outside of AI, machine learning, training, things of that nature was database functionality. You can actually load databases into GPUs, and you get that really fast speed. So there may be a way to like leverage GPUs as like a inline real-time database querying, like speeding up aspects of the network. I'm just saying you would be all over every trade reg if you had a way to put those to work and make them back profitable a little bit again. It'd be just an interesting story.
Very cool.
Jared, what was the deal? Everybody was using GPUs before. I can't remember what it's called, but they're one of the guys that was a member, when we're back in the day, he was doing something else instead of mining. He was doing something for diseases and stuff. Yeah,
what you were doing with those was
protein folding.
It was protein folding.
Thank you.
Oh, yeah.
Interesting.
And that may be a good token project. So if you think from like a token project, think of that type of capability that you could potentially launch a token on top of the Ethereum chain that was using leftover GPU resources for things like SETI at home was the very first big project where we were looking for aliens and protein folding and things of that nature.
Very cool.
I thought that was pretty awesome back in the day because it was actually a cause. It was for a great cause. Because I guess folding is used for other things that like you said, protein, other diseases. I mean, it was just to me it was pretty awesome.
Yeah, I think PlayStation, when they came out with the PS3, had like a whole application built right into it. And then they were doing it for COVID too.
Yeah, it's a fascinating use case for decentralized machines. Like there's people, if machines are online, they've got some spare power, some spare ability to compute. I mean, obviously you want to be thoughtful about how much of your machine is getting used. And have that. But yeah, I mean, that's an excellent way to use network compute for good, not evil.
I'm just thinking free marketing. If you can figure out a use case, it would be on every trade reg relating to crypto right now because people are trying to figure out what the hell do I do with these GPUs.
Hold on to it for 6 months, please. We got an idea.
Besides melt them down, extract the gold out of them.
Nice. All right, guys, it's 9:55, so I think it's a good time to end it. Thank you guys for joining. I hope you guys have the opportunity to go to Kelly's meetup tomorrow. So I put that in the Discord already. So if you can, it'd be really nice to join. So bring your questions.
Yeah.
Sweet. Thank you guys.
All right. Thanks for the time, everybody. Bye-bye.
I'll see some of you.